Everyone. Today we're going to tie logs with exponents and solving. So we're going to talk about how do we solve equations, and then what happens, and when do we need to use a logarithm, when do we not need to use a logarithm. So the first two questions are exploration. So how do I solve x squared equals 7? And then how do I solve 2 to the x equals 7? So the top one I see that I have x squared equals 7. I have to undo the square. So the inverse operation is the square root. So I can take the square root of both sides, and I can get an answer. Now the second one, 2 to the x equals 7. If I take the square root of 2 to the x, I don't know what that is, so that's not going to help. See it 2, so maybe I divide both sides by 2, and that's not going to work either. So today we're going to learn that you should take the log of both sides and then proceed from there. So to solve exponential equations, just like solving any other type of equation, we've got to use inverse operations. So if it's an exponential equation, which means the x or the variable is the exponent, we're going to use logarithms. We're going to convert everything to base 10 or sometimes to base e. And we're going to write our final answer both in exact form, so leaving it in logarithm form. And then if the problem says evaluate to the nearest hundredth, we can do that too. So looking at 2 to the x equals 7, what we need to do is undo the exponent. Okay, we need to get the x out of the exponent. So we're going to take the log of both sides. Okay, I know it looks more complicated at first, but then we can use the power property to get the x out front. And then we just have a multiplication problem. Log of 2 is a number. Log of 7 is a number. So just like we always have, if we have multiplication, we undo it with division. So we divide both sides by log of 2. So our final answer is x equals log of 7 divided by log of 2. They're both in base 10, so you can put it in your calculator if you need to, if the problem asks, okay, evaluate as a decimal or round to the nearest hundredth, round to 2 decimal spots. But if it says for the exact answer, it wants log of 7 divided by log of 2. So some helpful hints. What are we trying to undo? What operations? Just like you've always solved, if you're trying to undo addition, you use subtraction. Multiplication, division. Trying to undo a square, you use the square root. So first, we're always going to have to use the 4 basic operations if there's other parts attached to the exponential. And you're going to see that momentarily. Okay, here's a key. If the variable's in the exponent, you see an x or a t or an r in the exponent, logarithms are coming sooner or later. They have to be used to solve the equation. Now here's another hint. If the base is any rational number, so any decimal, any fraction, any whole number, remember it's got to be positive. Okay, we're going to use logs. If the base is e, if I see an e in there, I want to use natural logs because natural logs are going to be the inverse of the exponential constant e. So we'll look at two problems. First one, 5 plus 7 to the x equals 33. Things that stick out to me, I see an x in the exponent. So I know logs are going to come sooner or later. But the first step I want to do is get rid of that 5. So I'm going to subtract 5 on both sides. Now I'm going to take the log of both sides in order to use the power property because I always want to get the x moved out of the exponent. So I have log of 7 to the x equals log of 28. Log of 28 is still a number, it's just going to be a decimal. I can move that x out front using the power property. And then I can divide both sides by log of 7. So I get x by itself, so x equals log of 28 divided by log of 7, both in base 10. So I can use the calculator, evaluate it as about 1.71. So I have an exact answer and I have an approximate answer rounded to 2 decimal spots, depending on what the problem asks you to find. Now, this one's slightly different because I have e here. First step, still, I see a multiplication, so let's divide. Divide both sides by 34,500. Okay, this is a compound interest problem. Now I see base e, so instead of taking log base 10 of both sides, I'm going to take the natural log of both sides. Now, you could take the log base 10, but you're going to see in a minute that taking the natural log both sides is going to make the right side simplify very, very nicely. Still going to use the power property by moving the exponent out front. And now I have the natural log of e. The natural log of e is 1 because they undo each other. Base e, e to the first power is e, so this whole piece, this term is 1. And now I can just divide by 0.0071 on both sides. And I have a really, really long expression. It looks complicated, and it is. But this gets me my exact answer, and then if I needed to round, I use the calculator. I have a natural log button on my calculator, and I get approximately 20.83. So this is how we solve exponential equations. We use logs, we use power property, and get the exponent by itself.